In this video, we will be taking a look at the electron transport chain. And just a word of note that this is a very, very simple view of what is actually happening. It's overly simplistic, but it should give you a rough idea as to what is actually happening. I want you to take a look before we start at what you see underneath in the mitochondrial matrix. A lot of protons, we see some oxygen, and we see some ADP. Now the first thing that will happen is NADH loses some hydrogens and some electrons and then becomes NAD+. Now when that happens, ubiquinone or coenzyme Q10 gathers these electrons and protons and brings them over to complex 3. And in the process of that, more protons are pumped through complex 1 into that intermembrane space on the top. Now, ubiquinone drops off these protons and electrons to complex 3, where more protons are pushed through the top into the intermembrane space, and we have these negative electrons still in that complex 3. Also, what can happen is FADH can be oxidized and lose its hydrogens. We have hydrogens and electrons that go with it. Ubiquinone or coenzyme Q10 will be picking those particles up as well and bringing them to complex 3. Ubiquinone is kind of the transporter of these initial hydrogens and electrons. So it drops those particles off. The hydrogens get pumped and pushed through complex 3 upward into the intermembrane space. Now, cytochrome C. Cytochrome C is pretty much a shuttle that's going to go back and forth between complex 4 and complex 3. And for every electron that it transports, it's going to pump a hydrogen through complex 4. So it's transporting electrons back and forth from complex 3 to complex 4. Each one is going to push a proton through complex 4 into the intermembrane space. Now we have to get all of these electrons over from complex 3 to complex 4 one at a time. Cytochrome C can only hold one electron at a time. Hopefully you can see now why it's called the electron transport chain. Electrons are being transported through this lipid bilayer, and protons are actually being pumped upward into this intermembrane space. I'm going to show this step twice. We have an oxygen molecule in the intermembrane space, 4 protons, and then in complex 4 we have 4 electrons. All of those things, I rewound it so we could see it again, all of those things will join up. 4 hydrogen atoms, 2 oxygen atoms, and 4 electrons will join up to create 2 water molecules. Now I want you to take a look at what has happened so far. We started out with a bunch of hydrogen, a bunch of protons in the mitochondrial matrix, and we ended up with a bunch of hydrogen on the other side. So because there's so many hydrogens on the one side now, they're going to want to get to the other side. And the only way they can do that is through the ATP synthase. And as they're moving through the ATP synthase, they're going to spin this motor, and 3 or 4 of them will go through, and they're going to turn an ADP. So look underneath the ATP synthase, you'll see an ADP and a phosphate ion. Those two are going to want to get smushed together to turn into ATP. But in order to get smushed together to turn into ATP, they're going to need some energy. Well, they're going to get the energy from the motor on the ATP synthase. And the fuel for that motor is the hydrogens coming through that ATP synthase. So a handful of hydrogens are going to come through that ATP synthase. They're going to spin that motor, and they're going to turn ADP and a phosphate ion into ATP, which is our highly energetic, highly useful molecule. The storage of our energy so that it can be transported around our body and used in the places that we need it.